So thanks everybody for attending this session. My name's Jamie Maguire. I'm a software architect and web developer. And today what I'd like to share with everybody in the room is 3 introductions to some mapping APIs, namely the distance matrix, snap to road and the isochrone APIs. And those are available as services that you can consume through Bing. Before I break into all of the APIs though, what's kind of common, and just so I'm not really like repeating myself or wasting your time, is that each of these APIs are real easy to implement with your existing application, right? Okay, and you can do so with a language of your choice, right? And anytime you're sending data to or pulling data from these APIs, you can opt to use JSON or XML. As I say, it's the same for all 3 APIs that we're about to discuss. And so like the first one that we're going to look at is the distance matrix API. Now, at a higher level, what this API is really about is letting you calculate travel times and distances for sets of like origin, start points and destinations that you want to reach. And what you can also do is you can send in as additional parameters transport modes such as like walking, freight, or you know, motor cars and what have you. Over and above those sort of standard features, what you can also do with the API is it's got a layer of intelligence that lets it factor in predictive traffic. Okay, so using historical traffic data, it can recalculate and recalibrate the figures that it arrives at in terms of your travel times. And there's quite a few different use cases for the API. Okay, like the most common one up at the top here, really being being able to sort out travel time or distances based on your starting points and your end points. Calculating even your commuting time. So if you're moving house and what have you, and you're trying to figure out how long it's going to take you to get to your place of work. But one of the more common use cases for this API is the traveling salesman problem. I don't know, is anybody familiar with this? Yeah. So it's a little bit wordy, but basically given a list of the cities and distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the origin city, right? So as I say, it's a little bit wordy, so rather than like talk about the theory too much about that, I'd like to break it into an example of that, which is maybe what you're a little bit more interested in. So if we look at our salesman, he's got starting off location of say London, but he has to reach Leeds, York and Liverpool in one day. And one of the first things that we want to do is figure out what's the quickest place that he can get to. And this is one of the problems that this API lets you solve. Okay, and what I'm going to share is an example of this in Postman. So what we'll see is how we can construct a request in the parameters, send them over to the API, and then within like milliseconds we'll get a response back that tells us which location is closest and to start off for that salesman, and then that helps him plan his route accordingly. You can actually see a little preview of the code extract that you get back. Okay, so with that I'm gonna break out of the PowerPoint. I'm going to jump into Postman, which I will do here. Okay, and it's kind of hard to see, so I do apologise. Is anybody familiar with Postman? Yeah, I thought so. So I don't need to talk too much about what Postman is. For anybody that's not familiar with Postman, it's like a client that you can use to basically test web services, right? So rather than get your hands dirty with code straight away, it's a good way to just prototype and test web services that you're interested in. So up here I've got a request and I've got the endpoint for the distance matrix, and then down here I've got like some of the key parameters. So we've got origins. At that parameter we've got London, the latitude and longitude for London, which is sent in the value section here. We've got the destinations, which is Leeds, York and Liverpool. That came from the slide that we had earlier. We've set the travel mode, we've passed in the Bing key, and we've set the units and stuff that we want to report over. So, and what we do is like when we send that request over to the API, we get some JSON back, and I do apologise, it's hard to sort of see all of this, but if you can focus on this section here, you'll see we've got 3 results, so that's Leeds, York and Liverpool. Here we've got the distance and the travel duration. So if we wanted to like build an application programmatically that was gonna in real time, adjust the air travel and salesman's next location, we could do that using this API. Right? We just have to make requests each time we hit the next destination, and then it would recalculate these values and send them. And we can verify that information is correct by looking at, if we take that data or those starting points and destination points and feed them into Bing through the website online, what we can do is, so we can see up here, like the web service returned 194 as being like the closest. So up here we've got London to Leeds, so that's the closest place we can get to. It's 194 miles. London to York, 210, and London to Liverpool, 210. And as I say, like each time the sales guy hits each of these destinations, if we're building this application, what we could do is just make another call and then recalculate the next closest point, the next closest and the next closest, and stack them up like that. I've whizzed through that. Does anybody have any questions so far? No? Yeah?
What's the maximum points on it?
Oh, good question. I don't know off the top of my head. I suggest I have a quick look online, or I can check out for you and answer that for you after. Yeah? Thanks. Next up is Snap to Road. So, kind of like the name suggests, one of the problems that you can sometimes encounter when you're trying to build software that plots coordinates on maps is like the latitudes and the longitudes. They don't always map like the locations that you're trying to travel on. And it's not uncommon for data that's generated by systems to plot pins like in the middle of like places that just aren't travelable. So like I live in Newcastle. I know I don't sound like a Geordie, right? But so if you get the centre of Newcastle upon time, that the latitude and longitude that actually drops a pin on one of the main hospitals, right? And all right, if you're driving, you get the line of sight and you can check, which route you can technically go on. But if you're building software, it's not really ideal. So, as I say, it drops a pin in the middle of the hospital. And what Snap to Road does, this API, is it removes that problem for you. So that's the same hospital building, the same latitude and longitude. There's the location again in purple. It's on top of the hospital building, but when you feed your destination point into the API, it's got the intelligence behind it to figure out, well, what's the closest road that I can pin a latitude and longitude on, and you can see that in the green with the green marker, and that's the one of the key features of it. So if we look at an example journey. Up here, we're starting off in Newcastle, going through the suburbs and then into a restaurant. Over to the right hand side, you'll see that's the hospital. The suburbs, it's actually dropped a pin in a housing estate. And then the destination that we want to get to is highlighted in red by the red circle. But when you feed those coordinates into a map, it's just dropping them in places that you just can't travel on. But when you feed these data points into the Snap to Grid API, it's gonna find the closest road. So in the orange was the original location, and in the black pins you've got the the actual proper location. You can take that data and then you can feed that into your product. But like, don't take my word for it. What I'd want to do is for the developers that are in the audience is just like show you. We've looked at an example in Postman. What I'd like to do is just have a quick 5-minute demo of to show you how easy it is to consume the API in C#, and you'll see how straightforward it is to do that. So I'm going to launch into Visual Studio. Okay. Is that okay? Can everybody see that? Yeah. So this is just a console application, right? And all we're doing is we're creating an HTTP client. We're setting the endpoint. And we're still working with the same example that we had before, as Leeds, York, and Liverpool. So endpoint, the destinations that we're interested in reaching, some other properties that you can send into the API, so you can actually get it to return the speed limits for that road, and also the limits for any freight or HGVs that are traveling on that road. So you get 2 sets of data points that allow you to kind of plan more effectively, based on. Pardon? That the truck routing API, yes. There's a separate API called the truck routing API, and it factors even more data points for you. So like bridges and stuff is like an important one. Here it's just the Bing key. Output, we're just telling it we want to bring some JSON back, and then we send that over to the API. I mean, that's like, what, I don't know, 10 lines of code really. And you can basically get access to this sort of intelligence. So I'll fire this up, right? We've got a breakpoint, and this is where I hope the internet connection works. Yep. Now just look in the JSON visualizer. So we've got a successful request. And these are the snapped points to go from Newcastle through to the suburbs, and then to hit the restaurant that we wanted to go at. And then you can see we've got like the speed limit and then the names of the streets. So then what you can do is you can take those coordinates and then feed them into the system that you're building. And obviously you can just call that as many times as you want and build up a route for your freight. And that's just, I mean, that's not very readable, but that's just the raw data. It does have some other features. We kind of touched on them earlier. It can factor in multiple speed limits, different types of travel mode, and then we touched on JSON and XML data that you can use to process it with.
Can you prioritise the road types that it snaps to?
That I don't know off the top of my head. I don't know. Is that not, Mark? Would you?
You don't know the box ones snap to a back lane. You don't know this one's snap to a road.
Yeah, I mean, you could. I mean, I suppose in theory, what you could do is you could build some logic around that. You could have like a whitelist if you like, you'd some custom code to maybe manage those sort of exceptions or like non-travel routes, or you could pull the truck routing API off the shelf, and then to factor in the other data points that we discussed, like bridge height, the types of. I know that with the truck routing API that you can go right down to like the weight of the truck, because and you just wouldn't want truck to travel on certain roads, would you, based on their weight? I can find out for you though. we can find out. If you want to speak to us maybe after the session. So where's the next one? So that was a quick example of consuming one of these APIs in C#, and the process is the same for all of them really. You get your key, you construct the request, you send it over, and you pull back the data, and then you pass it out. Next one is the isochrone API. In a nutshell, what this lets you do is plot lines on a map. That'll tell you like how long it will take you to get to location X or Y, or where can you get to in X amount of minutes. Like some of the others, it's got support for multiple transport modes, predictive traffic, and then it can factor in the most optimal travel times for you to travel on. But it's the use cases for this that are pretty cool. Anything from stolen vehicles right down to recruitment. And what I'm thinking about when this API is deployed is like, I don't know, so you're building native apps. You know, you could build an app that surfaces, you know, the most popular restaurants within, you know, 30 minutes. You could pull down the cognitive services APIs. You could start mining data off the web. So you could say, right, pull me down all the locations within 30 minutes. Pull me down reviews for these places I've identified. Surface these in an app. There's quite a bit to go at. Stolen vehicles. How far could this car, in theory, have travelled from the point it was stolen on at the time it was stolen on? Even the emergency services. So you're provisioning a fleet of ambulances. Well, how, you know, where can these ambulances reach for this given time slot? And even marketing and recruitment. So you're looking for a new job. Well, how far can you, in theory, really go within a given amount of time? And you could build a hub using this API, and I think this is the beauty of these APIs, and I'm kind of bleeding into a little bit about what I'm going to talk about next, is that you could pull down other APIs from the cognitive services suite and then start to stack the layers of intelligence. You can pull down time-sensitive, location-based data, but then using text analytics and keyword extraction and entities, you can then surface other insights, but factor in location and all the other insights that the cognitive services can bring you.
I have a quick question.
Yeah.
With that map, if you can you kind of like save it as an image, because there could be cases where it's the same thing and you don't overuse your API key.
Mm-hmm.
So if you physically say, well, this is the truth for
Mm-hmm.
a particular thing,
Mm-hmm.
can you save that as like an image, so it's a static map, as it were?
Yeah, so what you could do is you could make it, I'm just thinking, so you could construct your request, you could send it over, and as you say, you may want to throttle the number of requests that you make for commercial reasons. When you pull that down, you can overlay the data, and I'm just going to lead on to that actually. It's a really good question.
I'm not sure under the Bing licensing you're allowed to cache any data you pull from the API there.
Terms of use say that you can store geocodes only whilst you hold a license. You can't store them.
Sorry, couldn't hear that. Were you talking about the licensing?
Yes, so terms of use say that you can store geocodes, geocode results, but you can't store any map tiles or anything like that.
Okay.
Is it sort of free to download and use the app, but you're limited by what you can store? Is that what we're saying?
There is free use, up to 125,000 transactions per year you can use for free. There are some restrictions on that as well, so if you wouldn't be able to have an asset tracking type application for free use. Any other BI or CRM type application or website you can use for free for up to 125,000 transactions.
And we'd find details on your website.
Yeah, or speak to us. Yeah.
Thought we might. Thank you.
And what happens is like when you construct your request, you get a set of polygons back. You get pairs of them, and then you can take those. And this is actually just some proper code here, some live code. You can take that and then use that to overlay polygons on a map, and then you can construct pictures of maps about specific regions and stuff. So that's kind of like the intro to the API, its features, what you can do with it. And what I'll do now is I'll break out into a very quick demo. And this is actually available online, this website, or this link, and I'm happy to share this content after the talk. So I'll just clear that. So it's kind of faint. I do apologise, it's kind of hard to make that out there, but what I'm going to key in here is like, well, on this test page I'm going to say how far can we basically go within 45 minutes if we're in the centre of London. And then I'm going to get the isochrone for that, and then hopefully this is going to go and make a call, which it has, and then so it's made the request, it's got the polygons, and then it's used the polygons that it's got back from the API to then plot the isochrone in the map, which is, and what we're looking at here basically is how far we can go from the centre of London within 45 minutes. And then what you can do is you can start to stack up these isochrones to build up regions that you can then use for, say, I don't know, like some of the use cases that we discussed earlier, whether it be fleet management, finding out how far ambulances can travel and all that sort of thing. So if I put in, I don't know, Reading, and I get an isochrone for Reading, and then we'll see we've got a little bit of bleed. It's kind of hard to make out there. See if the intersection bit's hooked up yet. No, but it's kind of hard to make out here. But there's a little bit of a different call here where there's bleed. So if you're planning fleets or logistics or truck routing, you could say, well, you don't need to provision any more resources past Maidenhead, and the API just helps you, handle situations like that. One of the things that we were discussing earlier was about, if you're moving house as well, how far are you willing to travel? How far do you need to travel? Where can you get to? And all those sort of things. So that wraps up an introduction to the distance matrix, snap to road, and isochrone API. I just want to thank everybody for their time and their patience, and I'd open the floor up for any questions really.
I'm not sure you're going to be able to answer the question, but it might be useful for anybody else looking at this. We use Bing for basic. We've got a private app we sell to our clients, which are licensed for Bing. Basic map that helps map views, that kind of thing. We accidentally strayed into using some of these APIs, which are actually classified in the premium kind of API.
Yeah.
And our license costs, the prediction went from around £3 grand a year, a like known user license, with being up to about 70 grand a year, which made them unfeasible. And also the restriction of if you're doing any asset tracking at all, tracking any assets, the price of tracking assets in Bing is absolutely horrendous. It's just not viable to use. It works really well for basic. We use it for here's the address, here's the location, viewing the app. It works really nicely. And also we do multi-route planning as well. So we end up just using a third party, just trying to build the algorithm on top of Bing, or just pushing the Bing users onto actually use a third party for that. If anybody else is looking at this stuff, we use OpenStreetMap data as well, which is open source and data quality. That's fantastic. Look at the premium APIs. A lot of our customers want to truck routing and things like that. It's just
Cost.
I think if we started down the route using the premium APIs, that might be different because we might put our pricing model differently. But I think it's because we started with the way we started down the user licensing.
Yeah.
So it caught us out, but it was quite a shock when we looked at it for the volume to sort of switch licenses over the cost.
Yeah.
Just blew up.
Suppose did you say you factor that into your pricing model from the yeah.
It came through it.
Yeah.
But yeah, it was quite a shock.
Yeah.
You see back then.
What's actually classed as an asset?
If you're tracking a GPS device, for example, that would be an asset. So something that's giving you a lateral doing reverse geocoding, that's classed as an asset. But you can, if you're not tracking assets, then you use a transaction based form, so you just consume transactions. If you are trading assets, it's a license per asset. The premium features are added to.
Could that asset be a mobile phone?
Yeah.
Gosh,
Depends on the use case as well. So if it's a consumer's mobile phone, then you could license that with transactions. If it's a business asset, then you need to license it per asset.
Yeah, one of my use cases with the telematics hub that aggregates lots of vehicle and equipment tracking into one hub, so we're tracking tens of thousands of assets. We don't hugely off. That's why.
Is there a number of free calls to get the assets, or is it from device one you get charged?
It's free calls for anything other than assets.
And the 125,000 is that per year? That's per year.
The snap to the road feature you had, do I get this right that it's just translating the single points to the nearest whatever road it
Yeah.
seems?
Yeah, and you get sets of
It
polygons.
thinks it's the right one.
Yeah,
But
and
it's not really what the picture showed, that at the end I get back information which really follows the proper road.
oh yeah, you get that back. You get, so if we, so that you get, so you get the proper locations back for the roads. So like that was the original. If you search for these places on the map, when you feed in your
If
locations,
you go back in your slides, you had this, well, the start before the snap on to the roads part. Another one, two up. Yeah, snap to road API up.
this one,
No, the two, three up. This one, yeah.
yeah.
So this is not true at the end. It just snaps the points to the map. But if I visualize this and I draw the straight lines, I'm still off the road. Is there a way really getting this apart from using ping as an algorithm?
I'm not sure.
So on this example, these are the points that were picked up from
Yeah.
the GPS device.
Yeah.
GPS devices are just triangulates.
Yeah, we are doing this. I know
It
what
could
I'm
be
talking
spot on
about.
and it could be
Yeah.
50 meters out. So the algorithms within the Snaps Road API work out the most likely route that was actually taken. So that's the
But if I
results
don't
back from
have
the
more
GPS.
points, how? That's the question. How could I get the visualization which really follows currently the road?
How can you get the visualization? So you can take those points, okay? You can take the data, where is it? So here,
You need the road network data.
Yeah.
And then you get the road network data.
That's the question.
so there's, here's the actual, here is the snap points. And here's the actual roads.
Yeah, I get this.
Yeah.
But the picture's still misleading.
You want to be able to follow the road network. So the
A straight line between the
polyline
points,
is
or a straight line between the points. Is there a way of getting? Are you doing this? Do you know how to get this?
need some to it, but we use the road network to get it.
Okay. So then you look up between these and you look where the road goes, and then.
I have a question about Snap.
But then you need again kind of
Mhm.
a routing there.
The image you
because there might be
showed,
crosses
it
with
snaps
the
the
road.
Yeah,
other
each
side
road
of the
network,
garage,
each road section has a section of
not the
tiles.
closest one to the
Okay.
road.
Each tile is a sort of road section, and you've got a polyline for each tile. And then you get the
Okay.
Yeah, like the bottom.
This one here.
The other side of the road.
Yeah, so
road section.
like to get to, like, where's the location? I don't have the other image, right? But you've got to actually head up there. See, if you're coming from the centre of town where the hospital is, you've got to go up that route to.
Yeah, but probably to get to the point, you would still have to drive around.
Yeah, you do. You got it. So this is like it's snapping to the road that you actually have to go on. It can't snap to the other side because, well, just the traffic's oncoming. So like you're coming up from centre of town, it's snapping to the road that you got to travel on, and then you've got to turn back round. So that's the route that you have to go on to get to the point where you've got to turn round.
But that's making an assumption you're coming from somewhere, and somewhere is at the bottom of
Yes.
the picture.
Yeah. So that's exactly right. So we see here, we were coming from like the centre of town. We're trying to get to here. Centre of town was in the middle of the hospital building, but with the restaurant and the other road that it thinks originally you have to travel on is in the top of a housing estate. So you're coming from Newcastle upon Tyne, but to get through to this restaurant, you've got to go up that road to come back down. It's just the road layout.
It's the path.
Yes.